Okay, so good morning, everyone. I'll try not to draw too long into lunch. So today I want to talk about microservices and Docker, two buzzwords for the price of one. What's with the stupid title? Actually, it's kind of difficult to hold a talk that's not ironic about microservices and Docker because we're kind of being attacked. Our attention spans are being attacked by containers, by microservices. Wherever you look on Twitter or the internet, you're only reading about hyperbole and how everything's great or everything's terrible or something in between. And of course, all developers are pretty enthusiastic because it's new tech, it's all fun, new architectures, we can play around. And vendors are more than happy to sell services or products around the whole business that's evolving. So today I try to look a bit past all the hyperbole and try to have a look at what can actually work and what can be useful. And if you try to do that, then you notice that actually microservices and containers kind of do work pretty well together. And that's what I would like to talk about today. So just a short overview. So I'm going to talk a bit about microservices, why someone would want to do that. Then I'm going to talk about microservices, why someone wouldn't want to do that. Then how Docker can save the world. And then a bit about what deployment options could be. Okay, so microservices, all about this thing. It's the monolith. I don't have any dramatic music, but this would be the time. So basically, this is the big system that's one deployment running in somewhere in your organization. It's huge. It performs critical business functionality. And you notice with time, you start adding features, you add people, and it becomes more and more difficult to add things because adding one thing breaks another thing, or it becomes harder to change things. And so you have these voices who are saying, so yeah, you have to take this monolith and you have to grind it up into something smaller that's easier to manage. And so what could that look like? So, okay, well, grind it up. So you kind of break it into smaller pieces, smaller services. They're separate deployables. You run them somewhere in your network and connect them together and everything's great. Well, the first thing, of course, you think when you read this or hear about this, so why would someone want to do that? Because it's actually a lot more complicated than what you had before, which was this nice little shoebox with all your functionality in it. And if you think about it a bit, basically it's basically the same reasons why we do things in our source code in development are basically just being applied to, let's say, a larger architecture in between systems. For example, something like modularity. If I develop code, I want to have modules, small parts. They're isolated. I can interchange them with some different implementation, for example. So I have a focused change that I can do. And this is, of course, something that's given by this separation of services somehow implicitly there. Then I have something in development called the single responsibility principle, where I kind of build a class that does one thing and does that well. It's kind of like the Unix way, have small little tools that all do one thing, and if you combine them together, the magic happens. And this is kind of what people are hoping from microservices. And well, of course, these blocks are all deployable independently. So I can, if I just want to change something in this yellow box here, well, I'll just deploy this yellow box. So I don't have a change that's rippling throughout my system. It's an isolated deployment. Maybe if I have load balancing and so on, it doesn't even have impact on my production system. So this is kind of a way to do a small change in source code and actually also get a small change in my infrastructure or my setup. And last one, bounded context is something from domain-driven design, which we also try to have in software, where we basically compartmentalize our business into isolated units or coherent units and try to model these in software with few interdependencies. And that's actually the same way that we're going to that we try to separate our services. So we're kind of seeing things we do in software also reflected in the architecture. And well, the overall goal is basically decoupling, because with a monolithic system, if I change one line in code, I have to deploy the whole thing. If I change one line in code, I have to test the whole thing. And if someone comes into my team and he wants to help develop this project, he has to learn the whole thing. I mean, maybe you can get away with only knowing parts of it, but since dependencies are kind of intermingled in a monolithic system, you have to kind of learn what this whole block does. And with microservices, you have fine-grained change, fine-grained deployment, and also easier to understand parts. So, but this sounds kind of engineering driven somehow. So it's more like tech stuff. Why would an organization want to do this? Well, again, basically because business changes. And normally for the craziest reasons, you probably all know this. that what sounded like a good idea yesterday sounds stupid today, and what we're changing today will be irrelevant tomorrow. That's kind of what we're doing in software. That's why software is so great, because it can adapt, but that also means it has to adapt. And if I have a monolithic system and I want to change one small thing due to interdependencies between code bases that aren't maybe explicitly there, one change can cause other changes to ripple. And this might not be too bad, but if I change something here, I change something there, I have all these changes that are kind of making waves throughout my source code base. And this can lead to what we call hacks in the business. So because, yeah, I don't have time, yeah, it looks okay, it's not totally clean, I'll just do it. And if you do this once or twice, this may not be bad, but if you do this over years or months or whatever, you just might notice at some point that it's becoming really difficult to change things. And actually, now you would need this big refactoring you've always wanted, but you're not going to get it because no one wants to pay for that. So not saying that this can happen with the microservice architecture, but at least there you have to have explicit boundaries between systems and communication patterns. So another thing that's pretty nice if you want to switch to microservices are that you can use different tools. So if you have one system, and that's, let's say, Java with Oracle and Spring and Hibernate and whatever, that's your tool set. Every problem you want to solve, you solve it with that tool set. And I don't know, I'm not going to ask for hands because it's embarrassing, but I think in each project I've been in, there was a SQL database, and at some point we implemented a key value store in this database. Because we needed something like keys and values, we had to use Oracle, and so you build it yourself. If I have independent systems which I can deploy separately, that also means dependencies can be managed separately. So I can use maybe Java and Oracle for one part of the problem, but maybe I need a key value store and Prolog for another part. Who knows? There might be the weirdest reasons to use different technologies, and the nice part is that you actually can do that if you deploy separate services. A really nice part about microservices is scaling. Since I have different isolated well, not isolated, but let's say independently deployable units. And let's say I have the green, the red, the blue service, they're running in my network. And I notice, wow, there's really a lot of traffic hitting this blue system. Well, the solution is pretty easy. I just scale this system. If I have a monolithic system and I want to scale that, I have to copy it. I have to put a second version next to it with the whole functionality, even if you only need a small part. One project I was in, we had one web service of, I don't know how much technology or how many different functionalities we had in there. One web service which took 90% of the load, and to scale that, we had several versions of the software running only to satisfy this one service, which was maybe 5% of the whole functionality. And the fun part is you can't only scale your systems, you can actually also scale your teams, your people. So let's say, okay, Blue gets a lot of load, but it's a fairly simple service. One database lookup, whatever. So anybody can do that in their spare time. But let's say you have this red system, has not a lot of load, but that has a lot of business logic in there. So this really, the meaty stuff of your business is running in this red service. Or it has a very high rate of change. So you just have to be able to be faster here than maybe with the other services. Then you just put more people there. So by aligning your services with your team structures, you can actually scale both ways, technically and from your team sizes. And it's actually also why a lot of people talk about Conway's Law when they talk about microservices, because Conway's Law says that basically the communication structure of your organization will be reflected in your software. Of course, it also goes the other way around. So if you structure your teams in a certain way, you can actually achieve certain architectures. So you have different screws that you can kind of turn and to move the whole thing together in one direction that you prefer. So it's all pretty nice. Of course, it can't be overstated that this microservice architectures aren't really a free lunch. So you're buying a lot or you're buying something for your money, but you don't know how much. And to just steal some credibility from someone else, this is something that Martin Fowler posted on his blog not too long ago, where he basically tries to kind of quantify the levels of productivity for monolithic and microservice systems. So he's basically saying, okay, if I have a monolith in the beginning, I'm going to be very productive. I have a high productivity because I have one code base. It's only one thing to understand. I can put my whole team around it. So I'm going to be productive. But as more functionality is added, as the complexity of my system rises, this productivity will drop. And at some point, we'll reach a very low level where it's really difficult to change the software. And I don't know about you, but I've been down here pretty often. And it's not a nice feeling. And contrasted with that, he says that microservices you're going to be less productive in the beginning because you have, let's say, higher complexity of the system design. But over time of the growing, of the complexity of the business parts, so to speak, the productivity won't drop that much. It might dip down a bit because you might have to restructure things, but it's not going to drop as strongly as with a monolithic system. Now the problem to this is that this isn't scientific. There's no numbers behind any of this. This chart is made up basically. And it feels right, sort of. So I do believe that it is sort of correct, that you will of course be more productive and this will somehow drop. But to me it's totally unclear where this intersection is, for example. So when is my monolithic system going to be worth less than if I would have done a microservice-based system? And also totally unclear what these differences actually mean. So it's, I would kind of would take it with a grain of salt, but the overall implications at least seem to be, they feel right at least. So there seem to be some kind of problems that might arise while using microservices. And I think the main one that's pretty clear to everyone is complexity. Because of course if I have suddenly more systems standing around, they're communicating, this is somehow more complicated than what I had before. And so complexity is new to us. I mean, all our businesses are complex. The software we're writing is complex. But this is actually the worst kind of complexity. This is accidental complexity. I'm only by the way in which I'm implementing the system, I actually made it more complicated than it had to be to fulfill the business requirement. So this is actually something bad from a business point of view. Nevertheless, if the long-term results if this in the long term can help me spare work later, then it can be worth it. But it's really, as with these curves, it's really hard to say when that's going to be. So complexity, more systems, they're connected over the network. What used to be a local call is now a remote call. And that can lead to new interesting failure modes. So for example, if one system starts getting slower than the other ones, then you can get congestion, you can get a kind of a jam in the communication flow, and this can affect other systems. Suddenly systems in front of that system are starting to get problems. So one failure of one service in my overall architecture can lead to ripples throughout the whole thing and everything collapses. So in the monolithic system, and, if there's an error, there's an exception, user gets an error page, life goes on, but other people can work. And so with a microservice architecture, you're definitely going to have to plan more for failure and resilience inside the whole system. Of course, your teams are also going to have to learn more skills because just developing won't be enough. I don't think that you can really implement something like this with keeping the separation between developers and operations teams. So I think you have to combine forces, which of course means both parts have to learn new skills. So you need some kind of DevOps. People have to learn how configuration management works. They have to learn what a Linux system is and maybe command lines and other crazy stuff. So and especially infrastructure, of course. So this is something that's definitely going to be challenging for teams, and you need a team that wants to do this. Yeah, and going closely with this, and it's kind of difficult in Germany, you kind of need cloud. So I don't really think that you can create a microservice architecture without using some kind of cloud. Just because you need the possibility to scale your infrastructure up, you need a new service, you have to start a new server. I was in one project once where we designed a beautiful system of small business-aligned services. They were talking with each other over web services or some message queues, and it was been really nice to deploy all of them singularly and have a nice setup. But we didn't have enough servers, so we put them all in 2 or 3 deployables, started them, and that was so they were talking to themselves basically over network protocol. And so this, if you can't get the infrastructure that you need to build these kind of systems, then it's not really going to work out. And to me, that also means that it's kind of public cloud, because I'm not saying it's impossible, but all private cloud implementations I've seen so far have been nothing like what you can get if you rent a server on the internet. And in most so-called private clouds, getting a new VM can still take weeks and cost thousands of euros, depending on how capacity planning is done. So this is kind of a bummer in Germany because of the data protection laws that are here. But I do have the feeling with cloud providers targeting Germany a lot stronger and building data centers here, and that even government institutions are thinking about some kind of certification for cloud providers. I think and hope that this is going to get better. Okay, there's also more I can talk about, but I don't want to overstress it. So, but testing is going to be more interesting with a distributed architecture. You're going to need some kind of automation, deployments, continuous integration. Everything, of course, you're doing today, but you're still going to need it. Your infrastructure will grow, more servers, more network, whatever. You might get a technology zoo because as soon as it's possible for people to use different stacks for different services, somebody will, if it makes sense or not. So you're going to have to work with that somehow. Of course, you have to monitor the whole thing. You're going to have to, evolve protocols and interfaces, all the fun stuff that we all like in distributed systems. You're just going to have them more. Security, it's not that important, right? And probably lots of other stuff I didn't think about. So basically what I want to talk about is these two, this infrastructure growth and this technology zoo. Of course, the zoo you can prevent somehow with standards or blueprints or whatever you call them. For example, I think Netflix had a rule very long that you basically used Java and Cassandra and some libraries of them internally. And if you wanted to use something else, you had to have a very good reason for that. So you can get around with these organizational constraints, but at some point you might need these different stacks, and then it's going to be difficult how to isolate them from the rest of your systems and how to keep them kind of well contained. And same thing with infrastructure, you have to kind of roll out your systems to different platforms or different nodes in your overall cluster, whatever. So wouldn't it really be great if we had some kind of software or framework that could help us with this isolation of systems and basically independence of the host system? And well, actually there is a system like that. It's called Docker. Does anyone not know what Docker is? Because I wanted to spare you the total introduction thing, because you probably already heard it a couple of times. But just to reiterate once, it's all about containers. It's this black box here. Okay, it's a gray box. And in this gray box, you basically package something like operating system, dependencies that your application needs, libraries and stuff, or JDK, and then you put your application in there. And this is basically one binary image and one blob, and I just push this to registry, either a public one or a private one, doesn't matter. And there, this registry it sits and waits. This image sits and waits. And so at some point, you have a host running here with a Docker daemon, and say, please run a container for me. This guy will go there to the registry, get the image, and start a container from that. So that's basically more or less simplified how it works. And if you need more, containers are generally more lightweight than virtualization. So you can start more containers on maybe one host than you could with virtual machines. And if that's still not enough, you could start more machines, more containers, more fun. And then you have something running, hopefully. Okay, so how can that help us with microservices? Well, basically, if you think about our red and our green and our blue system from before, we'll just make containers. Why not? So we'll package each one of these, create an image from them, push them to some registry, and we can then run them inside the Docker daemon on one host. And Docker also provides a mechanism for these to speak with each other. Each container has a virtual IP address. And using the linking mechanism of Docker, you can basically define communication routes. So green can talk with red can talk with blue, but red can't see green, and so on. So you can define this pretty much with the built-in mechanisms that Docker has. The only thing is this linking mechanism only works on one host. So let's say in the easy case, you can deploy all your services on one host. Why not? And so then you need the possibility to expose ports somehow to the outside world. So think that this is maybe the database, this is some service layer, and this is the web or whatever, and you have an incoming request, and red exposes the port here on the host system, and then you can get traffic from the outside go into red. Okay, so this is fine maybe, if it all fits in there. At some point you might have to scale. Well then, in the ideal solution, ideal world, you just put a second host there, second Docker daemon, and run all the containers again. So basically I'm exposing again the red system. I need some kind of load balancer in front, and then I can access the application running there. And they're all talking with each other. I can only see the red, and somehow this works. At least until you need something like persistence. So for example, normally you would say that each service should have its own persistence if it needs that. And suddenly you have 2 instances of everything. So you probably need some kind of replicated database or something so that you can actually build up this whole network in each host and still replicate state between those two. Or you can go the easy way and put your database outside of this whole thing in good old database, no Docker, no anything, and everyone just talks with that. So that's a fairly simple setup, which would be nice, might not always work, but if you have the memory and CPU to do this, this is totally possible. So talking about environments, how do we run this at all? How can we set this up? Well, in development, it's actually pretty easy. There's a tool called DarkerCompose, which comes from the Docker guys. Used to be called Fig. And basically what this does, it just takes my containers, starts them locally on my host, my machine here, and connects them with each other. To do that, I need some kind of descriptor file. Looks like this. This is a YAML file. I'm going to spare you most of the details. Basically, I have 3 containers here, database, service, web. Each one comes from a different image, which is pushed to a registry. And the interesting part is actually that I say that the service links to the database and the web links to the service. So basically, I'm telling these containers who needs a communication dependency to whom. And if you have a file like this, and here may be an interesting point, I can expose ports to the host system, so I can actually open a browser and connect to the system running here. And then I can just pass this file to DarkerCompose. It will talk with the Docker daemon and just start and configure everything for me. So this is, I'd say, a solved problem in development. There's some rough edges, but basically it works and can be used fine today. Okay, question is, how can that work with production? And production gets more difficult, as you probably expected. And there's quite a few solutions that are possible. I'd say probably as I'm talking, there's going to be 2 or 3 more. So I'm just going to show you basically three ways that I see that would be totally possible today and also sensible solutions. Option 1 is you don't really care about it and you use some PaaS provider. So you have some platform as a service provider who will give you the possibility to run your containers in their data center. What does that look like? Well, basically like this. I'm still going to have my image. I'm going to create that. That's always going to be our responsibility to create those. I push them to registry, and then I have this provider here whom I pay money for, and they have hosts, they have a data center or whatever. Each of their hosts is running a Docker daemon, or each of their virtual hosts. And basically they just offer 2 things, more or less. To simplify it, they have something for scheduling, so they have a way, internal magic sauce, how to actually run a container, find out which node can actually handle a new container, and start it there. And they give me some kind of API, where I can talk with it. So I just go here, I push something to this API. It's normally some kind of descriptor file. This may vary depending on which provider you're using. And then, same as before, they'll pull the image, they'll start containers, they'll connect them as I specify in my descriptor, and all is good. Yeah, well, yeah, maybe. There's quite a few options. I didn't even bother adding all of them, but you see there's some big names with their Amazon, Google, IBM, Microsoft, OpenShift, also Red Hat. Also smaller guys who are more specialized, but probably have more less older things to carry with them. And so basically each of these can do a setup more or less like what I showed you. Some support linking between hosts, some only support linking on a single host, but depends on what you need. Just a short example of what this would look like with Amazon Beanstalk and ECS. So Beanstalk is basically Amazon's thing it's the normal PaaS platform of Amazon, and ECS is the EC2 container service, which is a fairly new thing, where you can basically just also tell them to start containers on their Amazon instances. And you're probably not surprised, there's a descriptor file involved. It looks, well, it's JSON, it's kind of hard to read, but it's basically the same thing we saw with this local setup. We're defining some kind of images, like a database, service, a web, containers. We have images that we use. We have port mappings. We have links between the systems. So this is basically more or less just a different syntax for what we defined before. In this file you can upload to Amazon using the web UI, or you can use the Elastic Beanstalk, the Beanstalk command line client. And what Amazon will basically do for you, they're going to take some EC2 instances, fire them up. They're going to pull your images from the registry. They're going to deploy them to those instances. They're going to link them together, probably using Docker Link. I don't know exactly what they use internally. And they're going to add a load balancer if you specify it so that you can actually have multiple instances. And optionally, if you activate auto-scaling, they'll even scale for you. So if they notice, whoa, this host is pretty much under load, they'll just start a new one for it. So this is pretty nice. It works fairly well, depending on which provider you try out. I had some bumps, but generally something like that works okay. And of course, it's very easy to get started. To just get the first shot to see how it works. With very little investment, you just have to learn this descriptor file. You don't really have to take care of the configuration, which is always a pain somehow with complex setups. It somehow feels like an all or nothing solution with most of the providers I looked at. Basically, so it's fine if you just want to have containers, but if you want to mix containers with more conventional hosts or have your database hosted on your own premises and have a VPN connection or something, you're not going to upload a descriptor file for that. So you're going to have some custom building going on. Most solutions, apart from Kubernetes, are proprietary, somehow built. You can't really switch from one provider to the other. And the multi-container setup, so if you want to connect containers with each other, in some providers they have to run on the same instance, and in some they can be connected over several instances. That depends on which one you take. So this is nice for starting, but especially this part of migrating from my current setup to maybe using more containers might make it difficult for you to really start with a PaaS provider. So next option would be to do the thing that techies like to do. We just roll our own. And it's actually not that difficult. So basically, what do we need? The same thing as before. We're going to push some image somewhere to registry, and we have these hosts lying around. So what we basically need is some way to provision these hosts. So that means install an operating system and the Docker daemon so that they're ready. And then I need some kind of scheduling code to basically tell it again, please pull these images, please start containers on these hosts, and somehow configure them. So first problem, provisioning. That's, I'd say, a fairly solved problem in many data centers, let's put it that way. So you have something like, the typical configuration management tools like Puppet or Ansible or Salt. And you're just going to use those to install the operating system on your nodes, network them, configure them, and install a Docker daemon. So basically, you're going to use what you're using now if you already have some know-how in that direction, or if you have your own data center, for example. If you don't have anything, then you could look into Docker Machine, which is basically a tool also from the Docker guys to basically provision several types of servers so that they can run Docker containers. They support different backends like EC2, DigitalOcean, Microsoft Azure, and Google Container Engine, Google Compute Engine. And so this is, I'd say, the easier part. Second thing you need is scheduling, so a way to run containers inside your provisioned hosts. Now it gets kind of diverse at this point, depending on your setup and what you want to achieve. For example, if you want to, if you have using CoreOS, which is an operating system for running containers on your host, as your host operating system, you can use the Fleet tool, which is bundled with it, which you can basically use to schedule containers to run on hosts inside your overall cluster. Of course, the Docker guys also have a tool for this. It's called Docker Swarm, where you can basically, again, these machines that you might have created with Docker Machine, you can basically say, create a swarm from these, and then you can just say, I want to schedule a container somewhere in my virtual cloud, basically. If you want something bigger, more complex, then Apache Mesos is currently, I'd say, what most people are using. That's a more complicated setup, but it scales very well to hundreds and maybe thousands of machines. So there's very large Mesos installations around the world. It's not just used for Docker, but for other things. But of course, basically the problem that you have is just I want to somehow run a Docker command line on some host in my data center or in a cloud. So you can also do this with the typical configuration management tools, or you can also script it because it's basically not really difficult. The main difficulties the main difference is if you will have a fairly static setup in your data center where you basically know this container is going to run on this machine and this one is going to run on that machine, then a static configuration via scripting is totally fine. Of course, if you want to dynamically schedule things, then you probably have to look into something like Fleet or Swarm or Mesos. So whatever way you do, at some point you're going to have a Docker daemon and running containers. So the difficult part, again, is this orchestration topic. So now I have my containers running. How can I let them speak with each other? So we saw one mechanism is linking, only works on the same host. But now in a more complex setup, you probably won't have the luxury of running all of your services on the same host. So what can we do? Again, there's two options. The fancy one, the thing that people like talking about, is software-defined networking, which is basically a way in which you, over your existing network, you create an overlay network where you basically tunnel connections between Docker containers over normal IP, which can get pretty, allows for interesting topologies. You can even connect data centers over different cloud providers over an encrypted protocol. So there's a lot of things that you can do. I'd say Weave is probably the most well-known participant here. But this is kind of involves fairly sophisticated voodoo. So at least they used to do package sniffing and then tunneling over an UDP protocol. Not sure if they still do it that way, but it was fairly slow. Maybe it's gotten better in the meanwhile. I'm a bit wary about these smart and clever solutions. Another possibility is the Docker company, which basically is backs Docker. They bought a company called SocketPlane, which were also working on a software-defined networking solution for Docker. And since they're working for Docker now, I assume at some point one future version of Docker is going to allow something like this or some commercial offering, but I'm not aware of anything in that area now. So if you don't like the fancy, you maybe heard through my comment that I'm not so much a fan of fancy. I'm more of an old school guy, I guess. Then you're going to use something that's been fairly prominent in distributed architectures for a long time, which is service discovery. So basically I have some kind of registry where services can say, hey, where are the other guys? Where can I find my database? Where can I find my other service that I need? And so you can put something like a registry here. We used to have these UDDI servers, which no one liked. Someone still use UDDI? I thought so. Today, all the cool kids use something like etc daemon, which is basically a distributed key value store, which you can use in your data center. Or Zookeeper is fairly well established. And as a kind of variant to this, you can use DNS, which I kind of like because it's a fairly simple solution so that containers can discover other containers just by knowing the DNS name that they need. And two containers here are Console from HashiCorp, which is an open source project, and SkyDNS, which was kind of the first guys who did something like this in the Docker world. And so you can get an idea what this looks like with Console. Imagine you have now two hosts. I hope you can read it back there, it's kind of dark. I have host here, host there, and two containers running, and container one wants to talk to container two over the network. So I can't use linking, those are two different host systems. But of course, the hosts themselves are network connected. So basically what you can do with the setup is that container one can ask Console, hey, what's the IP of container two? So this container over here, and Console will just spit out an IP address. Okay, so how does that work? Well, basically you have a second component, the registrator, which subscribes to events from the Docker daemon. So basically Docker supports that you can basically subscribe to a feed where it says, now I just started a container, or now I just stopped one. And so you can react to these events. And so when this happens, registrator just publishes the IP address of the host, so not of the container here, but of the host system here, to Console under the name of the container. So that when the lookup happens the next time, container one gets the IP of host two and can connect here. And this can also be used for propagating ports, which we'll see in a moment. So this is actually a fairly simple solution for discovering containers in a disparate system architecture. Of course, it has one problem. If Console goes down, you can't talk with each other. Bummer. So of course, you wouldn't do a setup like this. Instead, you would do it more like this, which is basically run registrator and Console also as Docker containers. And then registrator can register or can listen to events from the local container, the local daemon, can propagate these events to Console over here. And then at least Console knows of all the local containers. And all Console instances talk with each other over the network using a gossip protocol. So basically they exchange which hosts they know over the network so that you have a single view which container is running on which node. So it's also fairly simple to use. So now we're on host 1, and we can just use the dig command line tool to do DNS lookup. And we say, OK, now we want to look up the name mongo.service.console. And when that happens, I get the dig output, which is kind of verbose. But the interesting part is actually here he found one host, Mongo Service Console, running under this IP address. So now console gave me the answer and gave me the IP of the host system. So at least a way to find that guy. Now I can look up another one. For example, now looking for a web service console. And now in the answer, I actually get 2 entries. So I get web service console, same name, but with 2 different IP addresses. So what this basically means is this container is running twice inside my network on 2 different hosts. So I can also ping this system. So because it's just DNS, and if I set up everything correctly, if I ping, I'm going to get here, it's going to this host here. If I ping it again, then now it's going to the other one. So first we had 11, now we have 10. So we're getting different results depending on when we call the server. You can ping again, now we're getting the first one again. So basically, using this, you can just use simple discovery and find whatever container you have running in your data center. You can also use port information because, as I said before, you can map ports from containers onto the host system, which is fine if you have a static setup. But what if you need a specific port, like 8080, and you have several containers on the same host which want this port? Then you can't just bind to that host port. So for this, Docker binds it. You can bind port, or you can create dynamic port mappings to arbitrary ports on the system. They'll just be randomly assigned. But in that case, your communication clients won't know which port to connect to. They'll find your IP address, but they won't find the port. So for this, you can also use DNS, actually, using SRV lookups, where you can basically ask for the server web service console, what kind of services do you provide? And here we get 2 answers, that we have console 1 and console 2 running, exposing this port. And these are the IPs that belong to those ports. So basically, I can use this record just use this information to discover ports of my services. Regrettably, SRV record lookups aren't really well supported in most application environments. Please.
This looks a lot like zero-config networking, Bonjour, or multicast DNS. What are the differences between multicast DNS and console?
Okay, the question was that this looks like a lot like Rendezvous or other protocols used for discovery on the Apple, or the Apple level, or some other services, and what the real difference is. Basically, from the implementation, I couldn't tell you. The main thing is that you somehow, what console makes easy is that you have a hook to register these events, that some container starts or stops. You can, of course, build this yourself. That's no problem. A colleague of mine, I'm not sure if he's here, no, he's not here. He built just this himself because you can this protocol is easy to listen to from the Docker daemon, and then you just have to know, okay, now I have to publish information to some DNS server. So there's no real requirement to use console for this. You can use a standard DNS and bind and do his own replication or whatever. This just makes it a bit more easy. Plus, you get the failover safety that they actually consent on which host they know. So you don't have the single point of failure.
Thank you.
Okay, so we can connect our containers together now, even over different hosts. We had this one thing in the other picture where we said, okay, we need some kind of load balancing. So if we have the same container running on different hosts, how do we actually know if I enter the name in my browser that I actually reach one of these hosts? Well, load balancing is a fairly well-established topic in most network systems. Of course, if you want to be simple about it, you could just use, in a console setup like here, DNS round robin. So that means, like you saw with the ping, each ping you do, each call, each name you resolve, you get a different IP. So you can just look up the IP before each call. Kind of dangerous with a lot of software systems. For example, Java caches DNS names forever if you don't tell them otherwise, which can make this kind of surprising because you don't really notice it until some node goes down. But basically, apart from the bit of overhead that you have for DNS lookup all the time, this is actually works surprisingly well, actually. Other possibility would be to have a static load balancer setup that knows all hosts and just forwards traffic there, but has a kind of health check to check if something's really running there. So if you know all your hosts, this could be actually a way to do it. The server might be busy with doing health checks that fail all the time, but it will work in the end. If you want to get a bit more fancy, you could use something like console template, where you can, so console listens, so the registrator listens to the daemon for events, propagates to console, and now you can listen to console for events. And if new hosts appear in the DNS table, you can basically recreate configuration files based on a template language. So a new container pops up, you have 3 instead of 2 now, and then you can rewrite the nginx or HA proxy config file on the fly, restart that service, and then you have an updated load balancer. So lots of fun stuff you can do. There's probably 3 other things I didn't think about, but this is kind of a well-working way to do this, especially if you're starting out and trying to expand your horizons. So basically to summarize, it's kind of nice, this approach, because you have full control. You can do whatever you want, more or less. You have a lot of flexibility. You can combine stuff you're doing today, the tools you're using today, with some new tools. You can decide how much of which you want to use. You can use the tools you know. And, okay, simple, it's not simple. It's simplish, maybe, or something like that. I didn't find a better adjective. So it's not totally difficult, but it builds on a lot of things you already probably know if you have a data center. You know how to provision systems, you know what DNS is, you understand load balancing, so a lot of your skills you can just apply to this without having to learn new, let's say, new vocabulary, new ways of building systems, and so on. And okay, console or etc daemon or whatever delivers a lot of other nice stuff. You get a distributed key value store where you can save configuration data, for example, for your applications. You get a nice dashboard with where you can see which systems are available. You get an HTTP API to configure stuff, whatever. Of course, this has a cost. I think it's pretty obvious. You have to play around a bit. You have to try stuff out. You have to see how it works. And it's, I mean, this is an approach that's used pretty much in a lot of places in production, just because there weren't any standard tools to do it. So people just started using these tools like DNS discovery or service discovery that they already know. But this is still, it's going to be your own snowflake that you built. So it's not going to be a common approach or the approach to do things. And of course, you have to document this and understand it, whatever. Okay, last option is kind of in between. You can be your own PaaS. So you can be your own provider, platform as a service provider, which means you have some kind of standard tools to build a PaaS in your own data center or in your own cloud that you use. And there's a few different offerings, but the only one worth mentioning to me is Kubernetes, which is basically a joint venture of Google and some other guys. Based on the experience that they have with running containers. Google has been the container running company for forever, basically. And so this is a full-blown PaaS solution which you can deploy in your own data center. And I could go into details, but I'm not going to do it, basically because this is a talk of its own. And it's, there's a lot of moving parts in the whole thing. So the other DNS setup was pretty simple compared with that. So just maybe for a slight preview, what I think about it. What I really like about it is basically you can host it either in your own data center, or you can also use it from another PaaS provider. So there are several PaaS providers which actually offer you to use Kubernetes, so you use the same configuration files you would use locally to run it there. It's of course more standard than rolling your own thing. Building your own thing is always difficult and expensive. It's definitely gaining traction, so I'd say from all the solutions, that's the one that's still going to exist 1 year from now, which isn't obvious in the Docker ecosystem. Stuff that's hot today might be gone next year. And especially there's a lot of big names behind it. So, of course, Google I already mentioned, Red Hat is invested there, Microsoft's invested there, IBM is invested there. Also the Docker guys are invested in it. So it's probably not going to disappear overnight. At least that's what I hope. That said, it isn't production ready. It's like 0.18 or something. I had a lot of problems running in different setups. There's a lot of interesting bugs you can run into. So I think it will be very interesting, but right now it was a bit flaky for me, but that's maybe just me. There's a lot of new concepts. You have to learn about pods and services and minions and masters and replication controllers. So you have new terminology, new configurations, new stuff that can go wrong. So it is the learning curve is definitely there. And I'm not really sure how to mix and match it with other approaches like hosting stuff on your own data center and tunneling over VPN if you have a cloud provider, or if you want to mix it with standard virtualization. I'm not really sure how good that's going to work out. So just to summarize, maybe using Docker for microservices, as always, it's kind of depends what you should use and what you can use. Sorry, there's no real cookie cutter pattern. I'd say basically, if you're thinking about if you have a data center today and are deploying software with or without containers in your data center and thinking about migrating to something more flexible or something more based on containers, I'd probably start with this roll your own approach. So doing something with your own service discovery with a very simple scheduling, which is more static than maybe a highly dynamic path will give you. But it's easier for you to understand and really try things out, because there's a lot of trying out that's going to be necessary. And this way you can basically select which speed you're going in. If you have a very clear-cut problem that's basically greenfield, apart from what you're doing now, then I'd probably go with Kubernetes to gain some experience with that. Hosted or your own, that's basically your decision. If you have a data center, you maybe want to host it on your own. Otherwise, you might want to do it in the cloud. Or as a second alternative and conservative provider, I'd basically say use Amazon, because they're the 800-pound gorilla. And I think what they're offering will get better over time. I think it's still a bit limited now, but their offerings are still fairly new. So I think this will be interesting, but you definitely shouldn't trust me. Think for yourself, find it out yourself. Basically, just some final thoughts maybe. So definitely, if you want to switch to microservices in a setup like this definitely has to fit your organization. That means you have to have the technical skills to do something like this. You also have to have the team structures to support something like this. So I would expect that you have larger teams, maybe even distributed teams, where this kind of setup would make sense for the extra complexity that you're buying, because you need different boundaries. If you have like 5 people and a not too complex system, I'd stick with a monolith and whatever you're doing now. So I wouldn't pay the price just for being able to say that you did it. So because it is complex and the rewards are definitely only long term. So you're not, in the short term, it's going to hurt and cost money. And if you don't have good engineering practices, so if you're not doing testing, if you don't do automation, if you don't do automated deployments, please don't even think about it. It's really, if those things aren't right, you're not gonna make it. And if you do, you might not make it, but at least you tried. Okay, as I said, I'm not really sure how to do it without the cloud, but I'm open to any discussion in that direction. Definitely what you can say is containers are here to stay, be it Docker, be it any other technology like Rocket or whatever might pop up. But I think that this mindset of distributing containers from development and running them on test, on production, is definitely not going to go away. So there might be a lot of hype around the whole topic, but this is definitely something that's going to stay for quite a while. So basically getting a feel for Docker is low risk. You can start that today. You're not going to break a lot of stuff. If you say it's unsuited, it's not going to cost you much. And if it's well suited for you, it's going to be a big benefit without too many changes. Thinking about microservices is definitely higher risk. So as I said, your structures have to match. And it's also very unclear to most people how to actually get started. So some say you have to start with microservices from the beginning, otherwise you have no chance. Others say, no, you have to start with a monolith and cut it up later. Both say the other guys are wrong. I actually don't know. I think it really depends on what skills your team has, what business you're working in. I don't think you can just say, yeah, it's like this and this is the way to do it. But anyway, I wish you good luck with any approaches that you might try out. And thanks you for your attention.